So my name is Will Tope. I am the Chief Commercial Officer at LiNa Energy. I'm really excited to tell you what we're doing. So we are commercializing these solid-state sodium batteries for the renewable energy sector. And they're free of lithium, free of cobalt, and free of manganese. And if you were to look inside one of these cells, what you'd find uniquely is a thin sodium-conducting ceramic. And we use that as our electrolyte instead of the conventional flammable liquid solvent in most batteries. Importantly, LiNa's innovation is not a new chemistry set. We have taken a proven but forgotten sodium chemistry set originally developed in the 1980s, but what we're doing is combining that with modern ceramics born out of the fuel cell industry. And it's the two things together which is what gives us our performance increase, but importantly, an extremely low cost, less than 50% of lithium ion. So where are we on that tech journey? Well, importantly, we're not doing individual button cells in glove boxes. Last year, we hit a key milestone and demonstrated our first energy storage systems with hundreds of cells, and we did that with both academic and independent commercial partners. But looking ahead, to make sure we're not just competitive, but also disruptive, we're looking to build bigger product intent systems. So this is where I get to really geek out, and the big question is, why do we need yet another battery? Well, we took a look at all the revenue streams for stationary storage and where's the money being made, and we split them here in two dimensions. So we looked at the size of the system from top to bottom. Do you need a gigawatt or a kilowatt? And then we looked at how long do you need that power for? Do you need it for 15 minutes? Do you need it for an hour? Do you need it for days? And you can see there's a lot of people making money out there, from microgrids through to large utility grade systems. We then took a look at all the different storage technologies out there, and that's across electrochemical, across mechanical, and across chemical. We mapped those against their sweet spot in terms of performance and cost. And one of the first insights we found was that there's a gap in the market between lithium ion providing economic storage up to 4 hours, and then all of the novel technologies coming in, like flow batteries, really only become economic at 10 hours or more. So you've got this gap between 4 and 10 hours. Sure, that's interesting, but why is it important? Well, it all comes down to the shape of how we use our energy. If you look at energy less renewables, there's two peaks in the day we can't fill with renewables. This is the well-known concept known as the duck curve. So that means if you have a load-shifting energy storage system, you want to get paid twice for both of those peaks, and that means you need a 4 to 8 hour system. Our intent is to exploit that gap in the market and win on cost, given that we're using abundant raw materials for our batteries. The second insight we had is where that duck curve is most pronounced tends to be where there's a lot of solar penetration, eating at middle of the day demand, but not the edges. And those also tend to be in high ambient condition markets, which are really prohibitive to the deployment of those incumbent technologies like lithium ion and flow. So we have commercial traction in place with those important beachhead customers at the microgrid scale in the UK. But everything I just said, it shouldn't be surprising that we're doing a lot of work in India, a key growth market for us. We're excited to have our first pilot projects online in India towards the end of this year. So hopefully I did okay in demonstrating the huge opportunity we have at LiNa. How on earth do we deliver on it? Of course, it starts with a team. We have 29 people based out of Lancaster in the northwest of the UK, and our leadership team combines core expertise in ceramics, electrochemistry, and material science with commercial insight from the Big Six and the energy sector. Secondly, how are we going to scale this business? So we are using manufacturing methods that are new to the battery industry, but proven elsewhere in other sectors such as PCB, food, and automotive parts. And that means we can leverage that existing infrastructure and know-how to scale our own business capital efficiently and stay in our sweet spot and stay in our ceramic lane. And a couple examples up there of us putting that into practice. So why am I here? All comes back to the fundraiser. The most exciting part about LiNa is that our advantage comes from the raw materials. And that means we don't need to chase scale to the same extent as our peers. Specifically, it means we can get to profitable manufacturing at a 100 megawatt hour facility, not a 10 or 20 gigawatt hour facility. So we are raising a Series A right now, a 17 million euro round, which will go towards delivering production intent cells off of a pilot manufacturing facility. And we're doing that to set ourselves up successfully for a Series Series B, which will fund that profitable manufacturing facility with tens of millions instead of billions. And that is the one thing I want you to remember today, is we are a disruptive, deep tech battery company that actually has profitability within arm's reach, and I think that is pretty cool. So would love to talk about the round with any of you in further detail here at the conference. If not, you can connect with me on my details up there. Thank you.